Ladies and gentlemen, welcome to ICAE 2022. And we are at the panel of green hydrogen emission mitigation. And I'm going to be the host of this panel. My name is Yuntian Chen, assistant professor from EIAS. And my partner, Dr. Haoran Zhang from Tokyo University and Dr. Dina from Asia Development Bank Institute will host this panel as well. And the purpose of this panel is to present researchers' thinking and latest research on green hydrogen. And we will focus on addressing the challenge of sustainable, reliable, and affordable green hydrogen in production, conversion, storage, and utilization, so that we can reduce our carbon footprint and embrace a cleaner future. Today, we have invited 4 speakers to present their latest research to us. The first speaker is Dr. Nandan Kumar Junadoha. He is the research manager from the Institute for Global Environment Strategies in Japan. And the name of his presentation is Making Hydrogen Society a Reality in Asia. Dr. Nandan Kumar, please start your speech. Thank you. You can share your screen now.
Thank you, Mr. Chen. So let me share my screen. Can you see my screen now?
Yeah, yes, we can.
Okay, thank you so much for the invite to be in this panel. It's a great pleasure to be in this panel. So we have at IGES, we have been working on hydrogen. I mean, quite recently, we started probably last year, but our work is mostly focused on Japan's hydrogen policy and also certain selected countries' policies about to develop hydrogen and consider that in their energy mix as countries are moving forward towards net zero strategies, net zero goals. So my presentation today is on making hydrogen as hydrogen society a reality in Asia, a feasibility assessment. So this is basically, in this presentation, I try to identify some of the plans that Japanese government has put forward in terms of hydrogen society and what kind of opportunities and challenges are there. And the main point I would like to focus on this presentation is about how Japan can possibly lead a regional cooperation and how countries in the region can have actually a collaborative initiative for developing hydrogen. So let me step into my presentation. As we all know, hydrogen's widespread deployment requires multiple dimensions of feasibility. I mean, it needs to be feasible from environmental perspective, economic perspective, and geopolitical perspective, and probably many other dimensions which we are yet to come across. So these feasibilities are extremely important for hydrogen to be sort of be in the mainstream energy landscape within Asia. So as we all know, the region is heavily dependent on fossil fuel sources to meet its energy demand, and hydrogen development is still at its sort of very nascent stage. So what kind of efforts are required for countries to sort of accelerate the promotion or accelerate the development of hydrogen is some sort of a regional collaborative effort. So that is going to be my focus, the focus of my presentation. But just wanted to highlight here that the International Energy Agency predicts that the demand for hydrogen is going to be substantially high in this coming years, something like 520 million tons per year in 2070, which is still not very high if you compare with the kind of fossil fuel demand that is happening across the world. But still, the demand for clean hydrogen is going to be extremely high, and that sort of highlights the fact that there is some sort of collaboration is required among countries. If you look at the regional development of hydrogen, I mean hydrogen development within this Asian region, we know that some of these major countries have already put forward their hydrogen development plans in varying stages. For example, Japan has a hydrogen basic strategy, which was actually brought out in 2017, and it also expects that other countries in this region also will have some sort of active role in promoting hydrogen within the region. And Japan's one of the ideas Japan has actually put forward is basically about the hydrogen society, how each country probably can actually utilize the domestic sources to develop hydrogen, and how actually within the region, how countries can collaborate for promoting hydrogen. In case of Korea, we also know that Korea also is another leading economy that is promoting hydrogen uh, as a major component in the energy mix. In the case of India, India has recently proposed a hydrogen mission, which was, I think, India has proposed in 2021, the national budget. But the basic development plans of hydrogen has been existing in the country from 1970s, but though there is no substantial development has happened so far. In case of China also, there are serious development plans of hydrogen is existing, and then government has also been promoting various initiatives to meet to give some importance to hydrogen development. At the same time, the main challenges which we all know are still existing, which is sort of protruding, you can actually say, when you look at this hydrogen scenario, which is environmental feasibility concerns, economic feasibility, and geopolitical considerations. Especially like environmental feasibility, the main point here is about how far hydrogen production can actually be cleaner processes. So if you see, even the renewable energy landscape also it is actually making substantial progress, but in terms of renewable energy sources, that is still not reached a level where it can actually it can be sort of to a large scale, it can be diverted for hydrogen production. So the production processes now is still depend heavily on the conventional or the gray or blue hydrogen uh, methods, which still have some sort of environmental impacts. On the other hand, the cost of hydrogen it is actually one of the biggest concern. That cost is comparatively, I mean, cost is comparatively higher when you look at hydrogen in comparison with other sources which are prevailing sources. So that is sort of pointing to the need of having some sort of economic viability as countries stepping into developing hydrogen. And the last point here is about the geopolitical feasibility, which, though the energy geopolitics is traditionally discussed in the fossil fuel context, even in the hydrogen, as we develop hydrogen, we also actually understand that geopolitics very well plays there in terms of trade, in terms of transportation routes, in terms of technology development and all those. Now, the point which I would like to mention here is about the concept called co-innovation, which IGS has been developing, has been working on for the past several years. So the co-innovation talks about technology development among countries within the region. So basically, we know that traditionally the movement of technology within a geography or between countries is used to happen through what we call technology transfer. But the technology transfer mechanism is probably though it is like, while it is seen as a beautiful term, no technology is usually transferred. The technologies are either sold or given on a subsidized rate to other countries. So while we are actually talking about development of hydrogen, we are still talking about how each country can have sufficient technology to develop it, to store it, and to use it. While the technology, there is a disparity in terms of the availability of technology within the region, there we will still have to go back to the technology transfer mechanism to see whether country A can supply certain technology or technology support to other countries. So as an alternative to technology transfer mechanism, we are proposing this co-innovation where there is an opportunity for the host country or the source country and the recipient country, which we see in the traditional technology transfer mechanism, and see how they can jointly develop technologies and jointly develop in such a way that it fits their geographical needs, it fits their domestic industry needs, or it fits their demand situations in the domestic countries, so in the domestic context. So co-innovation is basically about, unlike the traditional technology transfer, which is linear, co-innovation talks.
We only have 2 minutes left. Thank you.
Thank you so much. Thank you, Mr. Chen. So co-innovation is something which we see as a very powerful mechanism where as we develop hydrogen, we will have to ensure that countries will come together to develop technology that are critical for this. So this is sort of the mechanism which we see. I'll definitely be happy to actually answer some questions on this later. And we also find that co-innovation also has definitely a lot of environmental, economic, and social co-benefits, and there is a mutual relation between these two. And as a quick conclusion, I would like to highlight that Asia needs to prioritize green hydrogen over blue or blue or gray hydrogen, and also need to have a lot of importance given on technologies. So this points to the fact that greater collaboration in technology is critical for this region. Thank you so much, Mr. Chen, and all others for listening to my presentation patiently. Thank you. I'll stop here.
Thank you for your interesting talk. It's really inspiring, and we are looking for the hydrogen society in the future. Thank you. Okay, so now we will invite Dr. Shauli Jodekova to give a talk named Towards Hydrogen Economy in Kazakhstan. She is the acting head of Hydrogen Energy Competence Center and the head of Hydrogen Technology Research Laboratory at KMG Engineering. Dr. Shauli, please start your speech. Thank you.
Thank you very much for introduction. Good afternoon, ladies and gentlemen. My name is Saule.
Excuse me, Dr. Shauli, it's not the full screen sharing, it's the talker's version.
Oh. How about right now? Is it changed?
It's black screen right now. Maybe you can share it again. Like,
yes,
it's the speaker's view. It's not the full screen.
Can you see? Is it full screen? Not yet.
Nope, but we can see the words, so it's still okay now.
Okay. Good afternoon again. So today I would like to do a presentation about Towards Hydrogen Economy in Kazakhstan. I'm representing Hydrogen Energy Competence Center at KMG Engineering Company from Kazakhstan. Our competence center is the first hydrogen energy center in Central Asia. So today's presentation plan, will be the first introduction, short introduction about energy transition in Kazakhstan. Will be short introduction about activity of our center, and I will try to answer the main question of why does Kazakhstan need hydrogen, and how to establish hydrogen technologies in Kazakhstan. And conclusion will be with some recommendation for establishing a hydrogen economy in Kazakhstan. So let's start. So Kazakhstan, it is 9th largest country in the world. It's located in Central Asia. Also, Kazakhstan will known as a major fossil energy exporter, because Kazakhstan is 9th largest coal exporter, 9th largest crude oil exporter, and 12th largest natural gas exporter. As you see this graph, this figure, you can understand that more than 50% of power capacity installed by coal. So economy is driven by energy intensive extracting and processing of natural resources, including coal, natural gas, and oil. However, now Kazakhstan try to recognize the importance of climate agenda, decarbonization. So that's why recently increase the ratio of renewable energy sources, because Kazakhstan have high potential of solar power and wind power. But unfortunately, now we see that is not enough and it cannot be solution to all emission sectors. That's why we are considering about possibilities of utilization hydrogen and carbon capture system, carbon capture utilization system. Kazakhstani national energy company KMG, it is Kazmunaygas in Kazakh, it's mean Kazakh oil and gas. Last year started our low carbon development program. Under this program, established Hydrogen Energy Competence Center on the base of KMG Engineering Company. KMG Engineering is mainly work on research and technical and engineering support for the processes of oil and gas production. But from this year, we started also to focus on alternative energy, especially on hydrogen energy. So our competence center was started our work since April. So we just started from a few months ago. Mainly we are focused on the think tank and R&D support. We have a laboratory. So main office in the capital city in Nur-Sultan, and in Atyrau, in the part of in the west part of Kazakhstan, we have a laboratory which focused on the research of hydrogen technologies, especially hydrogen storage methods. Now we are working on the development of concept for hydrogen economy in Kazakhstan for Minister of Energy, Kazakhstan. So right now we faces with a lot of problems while trying to implement hydrogen. The main problem is lack of specialists and experts on hydrogen energy. That's why we have to develop domestic technologies and training of local specialists. In our center, we are working on comprehensive analysis of hydrogen technologies, because we have to know what is going in the world, how other countries try to solve this problem, which technologies are working right now. So also we are working with scientific and research applications. We make a collaboration with them. We are doing research projects on hydrogen production, hydrogen utilization, and CCUS project. Also, as I said before, we have a laboratory in the west part of Kazakhstan in Atyrau. Right now I'm located in Atyrau. And here in the laboratory, we are working on the experiments, how to prepare hydrogen storage materials. Also, we are participate as consulting for pilot projects of National Energy Company on implementation of hydrogen energy. So the next main question, why does Kazakhstan need hydrogen? So the first reason, of course, it is decarbonization. Unfortunately, emission targets were exceeded in the past. Right now, we have a regulating document such as Paris Agreement. If you see this graph, this is greenhouse gas emission, and this is the regulation by Paris Agreement. And we see that right now, it's not enough. So right now in Kazakhstan, we see increase renewable energy sources and also use natural gases, gasification, but the greenhouse gas emission is increasing year by year. That's why we are focusing on low carbon technologies, which include hydrogen and CCUS. Next, why does Kazakhstan need hydrogen? The next reason is carbon regulation and export potential. As I said in my previous slide, Kazakhstan is depending on fossil fuels and drive economy by export of natural resources. So right now, both internal and external carbon regulation can drive hydrogen adoption. Kazakhstani ETS is used emission sectors, but current CO2 prices is low. By supporting hydrogen technologies, we can solve this problem in the future, because we see that the amount of the carbon regulations task will be increased year by year. In the case of foreign carbon regulation, such as CBAM, it is $80 per ton of CO2, provides also good strong for Kazakhstan exporters. And another point, it is Kazakhstan's location. As I said, Kazakhstan is a Central Asian country, which is located between Europe and Asia, between two largest hydrogen markets. If we see the hydrogen demand in 2020 until 2050, we see that demand will be increased year by year, and the main hydrogen demand will be in Europe and in China. So it will be also a good opportunity for Kazakhstan, because China and Europe are the largest hydrogen markets in 2050. So establishing hydrogen technologies in Kazakhstan, let's think first about hydrogen production. We analyzed that hydrogen in Kazakhstan, we have a high potential of production of blue hydrogen, because we have cheap natural gas and coal. Also, current gas production is tightly used, but the resource base can be expanded. And abundant of coal resources, as I mentioned before, it can be source of gasification, and plenty of CO2 storage sites to launch hydrogen with CCUS system. Also, we have a great potential exist for green hydrogen too, because Kazakhstan has high potential of solar and wind power. So installed renewable energy sources capacity is tightly used for power generation, and green hydrogen projects should rely on the off-grid renewable power supply. By the way, last year, German and Swedish company Sevint announced about the large project on production of green hydrogen in Kazakhstan. So we see the potential of Kazakhstan. Kazakhstan might experience water scarcity in the future, and we see that it can be one of the problems to produce green hydrogen, blue hydrogen also. That's why we have to think more carefully about availability of water resources for low carbon hydrogen, and it should be investigated.
Dr. Soli, there is only 2 minutes left.
Thank you very much. So we see the cost of hydrogen in Kazakhstan will be cheaper to compare with other countries, and it will give a more opportunity to export hydrogen. Next, we have to think about storage and transportation. So Kazakhstan, located between Europe and Asia, it is a landlocked country. So that's why we are considering about transportation hydrogen by pipelines and railways. Hydrogen utilization. Mainly, hydrogen can be utilized in the power and heat system for Kazakhstan, in metallurgy, oil and gas sector, mining, production of construction materials, and in the transport sector. That's why we have to think about utilization hydrogen for near-term utilization area and long-term utilization area. With our result of analysis, which sector will be more important for Kazakhstan, and the possibilities of utilization hydrogen in those sectors. In the end, we want to share our recommendation how to establish hydrogen economy in Kazakhstan. At first, we have to clarify, define in the long term about the role of hydrogen and decarbonization strategy, identify target utilization sector, especially in steel, chemicals, oil and gas, and transport sector, and to think more about carbon regulation, because year by year, the cost of CO2 tax will be increased. So also, hydrogen economy will be a good opportunity for Kazakhstan because of potential of export. As I said, we are located in two largest hydrogen markets, such as Europe countries and China. For hydrogen production, we are considering about production of blue hydrogen and green hydrogen. For hydrogen storage and transportation, we are considering method of pipeline and railways. For hydrogen utilization, in near-term future, it will be ammonia plants, refineries, iron and steel factories. For long-term utilization, it will be power sector, residential heating, and transportation. And of course, to implement hydrogen economy, it is important support to R&D investment and operative regulations, which will be support implementation of hydrogen technologies. And in our center, we are looking for partners, collaborators. If you are interested on the analysis of possibilities, hydrogen production in Kazakhstan, green and blue hydrogen, on the experiment of hydrogen storage, such as preparation of metal hydride, and scale up this project, we'll be glad to be connected with you. And we believe to the potential of hydrogen in Kazakhstan, and we believe the power of hydrogen to decarbonize, to solve all climate problems. Thank you very much for attention. If you have any questions, I will be glad to answer.
Okay, thank you for sharing the story of Kazakhstan. And now it's time for the third speech from Professor Hui Zhou from Tsinghua University. This presentation will focus on the production storage of hydrogen with thermal catalysis. And Professor Hui Zhou, please start your speech. Thank you.
Thank you, Yuntian. I think
Dr. Shawli, could you please stop the sharing of your screen? Excuse me, Dr.
Yes,
Shawli?
yes, initially I stopped it. Is it okay?
No,
No?
you are still sharing your screen right now. Yeah, it's okay now.
Oh,
Yeah.
okay, thank you. Sorry.
Thank you.
can you see it now?
Yeah.
Okay, great. Hello, everyone. My name is Hui Zhou from Department of Energy and Power Engineering, Tsinghua University in China. So it's my honor to share some technologies about the renewable hydrogen production and storage with thermal catalysis. So the renewable hydrogen, which is the hydrogen coming from the renewable energy, which is also the so-called green hydrogen. So I would like to start from the energy consumption in China, US, and the European Union. So we can see that we are still relying heavily on the fossil fuels, especially coal, oil, and so the renewable shares is not very high. It's like around 10% in different countries. So therefore, there's a big challenge for the so-called the carbon neutrality. That is a goal proposed by many countries. So in China, we propose that to reach this goal by 2060. So there are many technologies we need to develop to reach this goal, such as to save the energy and to use more like nuclear energy and use solar energy and wind energy. And also we need the energy storage like batteries, supercapacitors, because some renewable energy are not very stable. And also so to promote the development of the car with the electricity, and also very important the carbon capture, utilization, and storage. So in summary, that to reach the goal, I think there's two ways. So one way is we still use the fossil fuels, but we need carbon capture, utilization, and storage. And another way is to develop the renewable energy, especially solar energy and wind energy. However, we need the energy storage because they are not very stable. So there are two ways to store this energy. To use the electricity, the so-called batteries or supercapacitors, and also the hydrogen storage, because we know that hydrogen is a low density fuel. So the renewable hydrogen, there's many ways to produce the hydrogen from the renewable energy. So we know that the traditional hydrogen production or the current hydrogen production is still from the fossil fuels. However, we can produce them from like bioenergy and solar energy or wind energy. But wind energy is also a kind of solar energy. So and to store the hydrogen, we can. So one way is to use the to convert them into some liquid or solid chemicals and fuels. So for easy transportation and storage. So one technology I'm going to talk about is the bioenergy to hydrogen, which also my research area. So what is bioenergy or biomass? The general definition is the organic matter derived from living or recent living organisms, such as the plant, like the wood, crops, and also the food waste, black liquor from the paper industry, and sludge from the wastewater treatment and the manure. And also we have some new energy crops and new biomass such as algae or microalgae. So from biomass to hydrogen, so one typical way is the biomass gasification, which usually needs air, oxygen, or steam at an elevated temperature more than higher than 500. So from biomass to syngas, and then we can separate the hydrogen from the syngas. Of course, the syngas can be used for other applications. So we know biomass is renewable and carbon neutral, and hydrogen is clean and carbon free. However, there are some limitations, such as this process usually we can only produce low hydrogen concentration, and it usually has a high CO concentration, which is harmful for the fuel cells and need high temperature and deactivation of the catalyst. So what we are working on is we combine the carbon capture and storage with the biomass gasification. So this whole process will be carbon negative. So we can capture the carbon from the bioenergy, and then we release only the hydrogen. So then we can solve these limitations. And so the typical way is to add a CO2 solvent in this process, and we can capture the CO2 and convert other carbon resources. And finally, we can get pure carbonate and pure hydrogen. So this technology can also be applied in other materials, such as plastic waste, algae, or sludge. And another technology is anaerobic digestion, which is the process to produce the biogas. So biogas is the mixture of methane and carbon dioxide. And from this biogas, so this is some industrial application in Denmark, and this one is in China. So from the biogas, so we are working on a typical reaction of dry reforming, which is the reaction between methane and CO2 to obtain hydrogen and carbon monoxides. So the main process need a catalyst. So it's very important to develop an active and stable catalyst. And also another one is similar is bioethanol. So we know that we can produce bioethanol, and the bioethanol, of course, itself is a very good material. So we can use this bioethanol also to produce hydrogen using the catalytic steam reforming process. So we know that hydrogen has a low density compared to the coal, compared to other like diesel, gasoline. So therefore, it's very important to get the technology of hydrogen storage. So there's many different technologies: metal hydrates, chemical hydrates, adsorption, liquefaction, and compression. And one important technology we are developing is CO2 hydrogenation. So from the carbon dioxide and hydrogen, we can produce some chemicals and fuels. This is also a typical thermal catalysis process. So this reaction can produce different products. Some very interesting material is some liquid materials.
Excuse me, there are only 2 minutes left.
Thank you. So methanol, among these chemicals, methanol is a very good chemical and fuel, because we can use methanol to produce other chemicals such as formic acid, acetic acid, and we can also use methanol in the fuel cells to produce hydrogen again. So this would be a cycle of hydrogen. The methanol economy is proposed by Professor Ola, called the Beyond Oil and Gas. So he proposed that methanol can be an intermediate in the future so for all kinds of chemicals and fuels. So all the electricity from the solar energy or wind energy can be converted to methanol finally, and then we can use methanol for all the vehicles and all other transportations and even some plastics. So from carbon dioxide to methanol, however, this reaction is very challenging. So there's many byproducts. And also there's a poor stability of catalyst. We can see how the catalyst get the deactivation. So we are working on to design an active and stable catalyst. So this is one of our typical work. We design a copper supported on MXene supported on silica catalyst to use this catalyst for the CO2 hydrogenation to methanol, which show very good activity and stability. So as a summary, so some technology about renewable hydrogen production from bioenergy with the thermal catalysis. We can do bioenergy gasification and anaerobic digestion with dry reforming, and bioethanol with steam reforming, and hydrogen storage with the CO2 utilization. So one promising technology is the CO2 hydrogenation to methanol. Thank you for your attention.
Thank you for sharing.
Thank you.
The production and storage are always the key points in hydrogen utilization. And okay, now it's time for our last speaker, Professor Cuiwei Liu from China University of Petroleum, East China. His talk is about the hydrogen gas pipelines. And because Professor Liu is on the high-speed train right now, we will play a recorded video of the talk. Dr. Dina, could you please? Yeah, okay.
Hello, dear Professor Chen and Dr. Zhang. Thank you for your introduction and your invitation. It's my pleasure to attend the 14th International Conference on Applied Energy, especially about green hydrogen in emission mitigation. Today, my topic is about study on hydraulic and thermal processes of pure hydrogen and hydrogen blending natural gas transportation. My name is Liu Cuiwei from China University of Petroleum, East China. Today, I will introduce 3 parts about my topic. The first one is about the background. Today, maybe everyone know the importance of hydrogen, and therefore I will not give much time to the background. Then we will focus on the blending process. My fourth topic is about the mixing and the stratified mass transfer mechanism in medium and low pressure hydrogen duct gas pipeline. Before focusing on the mixing mechanism in a pipeline, we firstly focus on the mixing stratification rule of hydrogen duct gas in high pressure vessel. From these pictures, we can see the hydrogen mixed gas mixing process includes 3 stages. The first one, aerate until the mixture is basically uniform, and then concentration stratification occurs. And finally, the hydrogen concentration distribution is stable, and the stratification reaches a stable state. We can also see the 3 stages in these 2 pictures. Furthermore, we should find out the Delimination law and sensitivity analysis of hydrogen mixed gas pipeline. From these pictures, the relations between the pressure, pipeline length, pipe diameters, temperature, and hydrogen concentration between these influencing factors and hydrogen ratio can be found out. From these pictures, we can see the hydrogen blending natural gas pipeline stopped and stood still, and the direction of gravity of the pipeline appeared obvious stratification. And with the increase of pressure, pipelines, and hydrogen concentration, and the decrease of temperature and pipe diameter, the hydrogen concentration gradient in the direction of gravity is larger. Furthermore, when the gas flows in the pipeline, what about the stratification? Then we established the simulation model, and the results can be seen in these 4 pictures. It can be seen that when running at a very small flow rate, the hydrogen gradually shifts to the top of the pipe with the flow, and the stratification occurs in the direction of gravity of the pipe. Therefore, it can be advised that the hydrogen blending natural gas pipelines are suitable for low pressure and high speed operation. In addition, the protective gas, which means the gas has a protection effect about the hydrogen embrittlement. The protective gas can reduce the effect of hydrogen embrittlement. Therefore, when the blending gases are blended more with the protective gas, such as the carbon dioxide, will the stratification occur? And these pictures can tell us the results. It can be seen from the picture that The protective gas will also produce concentration stratification due to its own gravity, and the hydrogen embriator inhibition effect of different parts of the pipeline is different. In the previous part, we introduced the stratification phenomena during the blending process, and then we will study the mixing layered mass transfer model for medium and low pressure hydrogen mixed gas pipelines. Two models are studied, including the component transport model and the mixture model. Between the two models, it can be seen that the difference is obvious. Then, the mixture model and component transport model are used for simulating the undulating pipe flow, the horizontal pipe flow. It can be found that for flow pipes, whether it is the mixture model or the component transport model, as long as the blending ratio is uniform at the initial stage, there is almost no stratification. And the last part is about the dual control multi-stage decompression and pressure regulation technology for the hydrogen blending gas pipeline. Firstly, we focus on the physical properties, and we found that the BWIS equation of state has strong adaptability to the calculation of the density of the compression factor of the blending gas, and the throttling effect of pure hydrogen and hydrogen blended natural gas are also studied. Furthermore, the pressure regulation ratio of pure hydrogen and the blending natural gas also reviewed. And when the shuttle valve is closed, how the pressure changes with time are also studied. And all the conclusions can be drawn from my facilities. It can be seen in this picture. Thanks for your listening. If you have any questions or if you have interest on my topic, you can contact me by the WeChat and by my email. Thank you very much.
Okay, thank you, Professor Liu, and for the presentation, and thanks, Dina, for the sharing. And it's promising to achieve large-scale, long-distance, and low-cost storage and transportation of hydrogen. So we have about 5 minutes for the questions. Is there any questions? I've seen some questions in the chat log, but it seems that they are solved. So is there any other questions here? No questions? Okay. Since we don't have lots of time, I have only one question here. So what do you think for the all speakers are the most likely breakthroughs in the hydrogen in the next 5 years? So any speakers want to answer this question?
Yeah, Mr. Chen, could you please repeat the question once again?
Oh, I mean, what do you think are the most likely to be the breakthroughs in the green hydrogen in the next 5 years?
Okay, I think, I mean, if you're looking at actually like breakthrough technology, I think it is quite difficult to predict, but what could be most important approach in promoting green hydrogen is a technology collaboration, because that your question actually sort of sounded similar to the point which I was raising, that in order to address the technology disparity, availability in the disparity in availability, greater collaboration among countries is required. Especially if you look at the Asian region, you can see that Japan is have a pioneering role in hydrogen technologies, and also have Korea. And but at the same time, the major fossil fuel demand is coming from many other developing countries in region, and we need to actually think of substituting this fossil fuel demand with sort of adequate supply of hydrogen or clean energy sources. That points to the fact that technology will have to play a key role, and to address the disparity of technology, a greater collaboration is required. So my presentation actually focused exactly on this topic. Thank you so much.
Thank you, Dr. Nanakuma. It's a very good point. And if there's no other answers or questions, we will move to the next part of the panel. It's a panel discussion hosted by Dr. Dina. Dina is a research fellow at the Asian Development Bank Institute, and her research interests include energy policy, particularly renewable energy, energy efficiency, and energy storage. She is currently a guest editor for the Applied Energy Special Issue, Integration of Renewable Energy Systems, Perspectives on Investment, Technology, and Policy. And I will hand over the meeting to Dina now. Thank you.
Thank you, Tian, for a very kind introduction. So we're starting our panel discussion here with wonderful, great experts from different countries. So I won't go to a long introduction of bio because in the chat there is a link to full bio. So we have today 3 panelists: Matthew Geze from HDF Energy Indonesia, power producer dedicated to hydrogen power, and also Victor Nian from Center for Strategic Energy and Resources, independent think tank based in Singapore, and also Eric Zussman, Institute for Global Environmental Strategies based in Japan. So we have great panelists from experts on hydrogen from Asia, different countries from Asia. That's great. I'm very interested in hydrogen investments, and I learned that main barriers is like cost of production and also like the whole ecosystem of supply chain and what's called hydrogen society. So I would like to ask our panelists some questions related to that. How can we like promote? Overall, I want to learn how we can promote investments in hydrogen. So my first question to Matthew Geze. So first I will ask questions myself, and then we will pick questions from audience. So audience, if you have questions, you can put them in chat, or later when we ask, you can unmute yourself and ask. Okay, so first I'll start with questions. Matthew Geze, since you are the hydrogen producer, where and how do you think hydrogen projects will be bankable and like cost competitive?
Well, thank you, Dina, for the very interesting question, and thank you for the invitation to share our views today. So I will try to make a not too long but a clear answer, because this topic is very critical, and we see that it's often a bottleneck, or it can be often misleading when you talk with governments, utilities, investors. Most people are interested by hydrogen, but everyone says, but let's wait 10 years, 15 years, let's wait hydrogen to be at $2 per kilogram or €2. And we see that everyone is stuck on the price discussion, while we believe that there is something to do on the short run. So firstly, I would like to start by something positive, is that we see worldwide there is a momentum around hydrogen. Many countries want to make green hydrogen happen, especially in Europe, Japan, Australia. We see a lot of pilots, a lot of subsidies dedicated to hydrogen. And that is very positive because it will help the industry to grow. It will help for the suppliers to scale up their manufacturing capacity. It will help to reduce the cost of the systems. But in the meantime, today, when we talk about hydrogen and green hydrogen, we see that is not a commodity. If you wake up a morning and you want to buy green hydrogen, you ask to the market, can I buy green hydrogen? You will see that it's not available. You need, as you mentioned, we need to develop an infrastructure, supply chain, as we did decades ago with LNG. And that will take time. And for sure, for the first projects to come, they won't be the cheapest because you really need to develop the infrastructure from scratch. But that being said, on the long run, we know that with the economies of scale and with the programs which are being implemented worldwide, we should be able to reach this competitive price of $2 per kilo or something. But the big question is, what do we do in the meantime? Should we wait 10 years for the hydrogen to be massively available and affordable, or can we find a room in the market from now? And we believe that there is a room outside the subsidies that we see in Europe. And when we talk about Asia, so personally, I'm based in Jakarta and I handle Asia region for HDF. There are many middle-income countries in Asia which won't have necessarily the capability to duplicate the billions which are sent on the market in Europe, in their country. They won't be able to afford that. And we believe that in such countries, maybe the right focus will be to address the power sector, because we see that in some contexts, island grids, grid edges, there are specific challenges for the utilities, challenges to bring the coal and gas over there, challenges to integrate intermittent power, and the hydrogen produced locally can be a way to maximize the penetration of renewable energies without disturbing the grid stability. And when we develop such projects, we can address the commercial scheme of the green hydrogen projects, because we don't sell the molecules. We don't need to develop the whole infrastructure because everything will be built on site. And at the end of the day, we will sell the kilowatt hour. And if we have a bankable PPA, we will have a bankable project, and we can implement a large-scale green hydrogen projects. Because in terms of bankability, we believe that the technology is bankable. The technology is proven. If you look at what is an electrolyzers, fuel cells, who are the key suppliers, we see that both the technologies and the suppliers are bankable. But today, the bottleneck is the viability of the commercial scheme, as we discussed. So implemented in the power sector, we see that it can be bankable. And as an example, at HDF, we are building a project in French Guiana. So this is very far from Asia. This is in Latin America. This is a grid where the cost of electricity is expensive. It combines all the context I mentioned. And we saw there was a need to get more renewable energies, but in a stable manner to the grid. And we used green hydrogen to do that. And today we have a $200 million project under construction. It involves, among other devices, 18 megawatts of electrolyzer. We have commercial banks involved, like SMBC from Japan, BNP Paribas from France. So we can show that it's doable, bankable, to do a green hydrogen projects worldwide, and indeed we can duplicate that in Asia. And we have started to do that, for example, in Indonesia, Philippines, we have a pipeline of projects under development. We are discussing with ADBI, they are part of some studies in Indonesia, and we are duplicating that also in Vietnam, Cambodia, and Thailand. I see you are in Japan. I will be in Japan at the end of the month to explore the synergies over there. So as a conclusion, this is the way we see that we don't need to wait a decade to make green hydrogen projects happen. We can find a commercial scale application in the right context for the power application. So thank you.
Okay, great, Matthew. Thank you so much. It was great to hear about applications of hydrogen in power sector for grid stability and to drive costs down. And especially that you focused on green hydrogen, because I think that's the main interest for our project, this one event. Green hydrogen. Thank you very much for focusing on green hydrogen. So next question I would like to ask, continuing with the Southeast Asia region. I think Southeast Asia have great opportunities to produce hydrogen and then maybe to export it even to countries like Japan. I saw recently a presentation from Japan where they showed map like some opportunities to bring hydrogen from Southeast Asia to Japan. So Victor, I would like to ask you, what are strategic considerations in establishing sustainable hydrogen ecosystem, the whole supply chain in ASEAN? What is your view?
Oh, thank you, Gina. Actually, thank you for asking the question in a way you call it a hydrogen ecosystem rather than a hydrogen economy. Very traditionally, we all say, this is supposed to be a hydrogen economy from production, transport, everything, et cetera, then, we can support this whole energy transition with that scheme. But at the end of the day, if you think about it, it's actually the ecosystem that needs to be at play from across the different value chains of hydrogen so that really, hydrogen can have a meaningful role to play in this energy transition space. So, of course, in terms of hydrogen as an option to decarbonize, and very easily, we think about green hydrogen, we think about different colors. Today we talk about really a wide spectrum of colors of hydrogen. You get colorblind when you look at, what source of hydrogen, this hydrogen is being produced from. And of course, in the Southeast Asian context, ASEAN context, I think if you've been living here for extended period of time, you would realize that this region actually is quite rich in natural resources. Although it's unevenly distributed, we do have some countries are blessed with a lot of natural resources, coal, oil and gas in certain countries. Unfortunately, that's fossil fuel, right? But we have those resources. And of course, in certain part of Southeast Asia, especially the northern part, we have hydropower, and that's from the Mekong River, Laos and Cambodia. So in that spirit, we were looking at things like the LTMS, Laos, Thailand, Malaysia, Singapore. Is a Trans-ASEAN Power Grid project where we try to establish interconnections to bring green electricity across ASEAN. And of course, in that same spirit, we're also thinking about, well, if electricity can be distributed across ASEAN through some kind of framework enabled by some kind of infrastructure, can hydrogen play a role? And this is where the competition gets interesting. If you have renewable energy, you can produce electricity, and that's green electricity, that's no doubt. But hydrogen is actually the next step of electricity. So you don't produce hydrogen directly from renewable. So you produce hydrogen from electricity, and electricity has to be made produced from some source. So in a way, of course, today we understand hydrogen is not really an energy resource. Hydrogen is more of an energy carrier. Right? So very quickly, you realize there's going to be a competition between green electricity and green hydrogen in places where there's not enough renewables for you to achieve whatever decarbonization goal. So then if you look at outside of ASEAN, you look into, say, Europe or even the Scandinavian countries where they have a lot of wind in winter or in certain periods. And there's so much excess wind or wind electricity, they are selling wind power at a negative price. And those are the perfect opportunities to produce hydrogen and assume that there will be an ecosystem where they can bring hydrogen or a form of hydrogen in ammonia or liquid organic carrier or some other form to Southeast Asia. And that will be really a nice way of bringing hydrogen in. But here's then the question is, well, the way to bring hydrogen all the way from that part of the world, what are the means of bringing them? If it's still through a conventional bunkering fuel, from say a chemical tanker that's fueled by traditional fossil fuel, and that is not going to do any good to the environment, right? So, and of course, we are hoping that maybe in the future the maritime also be decarbonized with different types of fuels, and ammonia is one of them, right? And hence, now going back to Southeast Asia and thinking about, well, now we are looking at ammonia as a fuel for bunkering. And also ammonia is actually a hydrogen carrier, right? In the long distance transport, you will hear the industry arguing, rather than transporting hydrogen at ultra low temperature, high pressure, we can transport ammonia. Ammonia safety regulations, they're all well understood. And it is a carrier of hydrogen. So rather than spending extra energy in bringing hydrogen in and out of ammonia, why don't we use ammonia as a fuel? Right? Ammonia also has really established industrial process to manufacture it. It can be made from urea. It can be made from some specialty chemical plant, and the handling of which is also well understood in the regulatory space. And so why don't we work with ammonia as a fuel? And true enough, there are companies, for example, Mitsubishi Heavy Industry, Siemens, they are already developing ammonia-fired gas turbine. And for example, Hyundai is also developing two-stroke marine engine. And not developing, they're already selling those engines ammonia fueled. So in a way, you also see another layer of competition, another level of competition to hydrogen. Right? But in a way, this is also a part of the hydrogen ecosystem or hydrogen economy, if you think about it. In the refinery sector in Southeast Asia, which we have a lot of them, hydrogen needs to be produced as a feedstock. So these guys produce from gray hydrogen. They use steam methane reformer to produce hydrogen. They need to do that because it's a feedstock. So what is the next step for them? Can they adopt green hydrogen? Well, the answer, I guess, probably in the short term is no, because that cost doesn't justify. And to bring hydrogen from outside the plant, there will also be cost and safety issues. Right? Within the plant, it's all well integrated. If you look at Exxon, for example, ExxonMobil plant, it's all well integrated. Hydrogen is internally produced through some pipelines and then being used within the plant. But now if you want to introduce external hydrogen supply from a terminal, say, for example, if you think about hydrogen, Singapore, which is small enough, right? We have LNG terminals, and assume that we have the experience of having hydrogen storage, and you bring that storage 3 or 4 kilometers away from the refineries, probably a longer distance. I'm not really exactly sure the number, but it will be several kilometers away in distance, right? So what does it take to enable such local transportation of hydrogen or distribution of hydrogen from two things: infrastructure development on the hardware side, by the pipeline, and there you're dealing with metal embrittlement issues or other issues. On the software side, the infrastructure so that's talking about safety governance, safety standards and regulations, which at the moment doesn't exist. I mean, Singapore and in most part of Southeast Asia, we don't really have a well-defined standards for hydrogen. And we also don't have a well-defined legislative and regulatory frameworks around hydrogen. So if you want to have a project and you ask the government, hey, can you approve my for example, hydrogen storage project? But the one big question the government asking is, so what procedure do I follow to approve your project? And what risks are we looking at? Yes, of course, there will be cost issues, there will be infrastructure investment issues, and Matthew already mentioned, but there's still a whole suite of regulatory issues that literally has no answer at this stage. And of course, assume that we get over those issues, we somehow manage to get some kind of infrastructure, hardware, software, both set up, and now we want to adopt hydrogen. I think then the most critical question is, then what really is the market size in Southeast Asia? Right. Of course, in Southeast Asia, of course, ideally in ASEAN, we try to look at ourselves as if I have to use the word union, like the European Union, have a uniform market where everybody adopts hydrogen, trade hydrogen, buy hydrogen from this market. Then the question is, what kind of downstream use case scenario are we looking at? Are we looking at hydrogen-fueled gas turbine for power generation? Are we looking at hydrogen fuel cell cars? Are we looking at hydrogen as an industrial fuel for cooking or for other industrial processes? So what is it that we're going to use it? And you see, for every one of these applications, it has its unique technological challenges. And also investors always want to be on the conservative side and ask the question, what is the mature technology that I should go in and scale it up? And probably also the question is, what this mature technology to a tier technology readiness level of 6 or 7 probably doesn't really exist. And even if they may exist, there will still be a tremendous amount of risk to go inside and invest in the first of a kind project and in Southeast Asia, right? With a big uncertainty of how big and how sustainable the hydrogen market is going to be in this region. But having said that, the region is looking at energy transformation, future energy transition. We want to move away from fossil fuel, right? And of course, a lot of people will be arguing, hydrogen really is hydrogen probably is the final destination for natural gas, right? So assuming that we're going to have that the beautiful picture, and this Trans-ASEAN Power Grid projects is going to be sustainable, be successful. And especially I would say that today, several ASEAN countries are looking at nuclear energy. Right there you have Vietnam, you have the Philippines, you have Indonesia. Right? So they are all looking at nuclear energy for industrial development. So today, in today's context, you can think about net zero carbon industrial park, where they will develop their future economy on top of carbon-free energy. And of course, because over 24 hours, the demand for electricity changes. So it's just same as, integrating renewables. When there's too much renewable, you try to produce hydrogen to address the grid issues. And same thing for nuclear, since it's base load. When our demand changes, When you have excess electricity, you can then produce hydrogen from nuclear energy. And nuclear energy being a base load, if countries are going to adopt it in a large scale, at some stage, they may create an excess of electricity, which can be dedicated in producing hydrogen. And assuming the entire ecosystem is ready by then, the benefit is, rather than ASEAN being a region with a prediction of becoming a net energy importer, which is already happening as we speak, with this combination of renewable nuclear and hydrogen, ASEAN might actually become a net energy exporter for clean energy, for ammonia, for hydrogen. So one of the projects that is happening ongoing in ASEAN is this Brunei, Japan project. I think it was called Advanced Hydrogen Demonstration something project. It's called AHEAD project. So the idea is to do hydrogenation of a hydrogenation process in Brunei, ship to Japan, and Japan will do dehydrogenation to get hydrogen out of it. So in a way, this becomes like ASEAN-Japan supply chain to supply hydrogen. I don't know exactly what the color of the hydrogen is. It's probably gray or blue hydrogen. And we hope that it probably become green hydrogen in the time to come. But the practical challenge is, would ASEAN have enough renewable to produce hydrogen at a scale that is cost justified? And then again, if you recall what the argument that I made earlier, if you don't have enough renewable, or if the renewable resources are somewhat limited, why don't stay with renewable electricity and try to manage the grid with battery energy storage, for example, with some other measures in smart grid and dispatch and load shifting, right? I mean, if you're talking about Trans-ASEAN power grid, then maybe there are more variables to play with to make the grid more flexible, because you have demand happening all across the Southeast Asia, rather than trying to produce hydrogen out of the renewable, which is limited, and suffering additional conversion losses in it, right? And of course, you also have an issue with the long distance transport, long-term storage, right? This whole suite of issues. And then, of course, government can say, well, electricity is more immediate, hydrogen is longer term. We need to understand the risks and how the risks associated with it, and how to mitigate those risks from a regulatory governance perspective, right? And then, of course, I will say the last part of the ecosystem is also insurance companies. When something happens, somebody needs to pay the bill, right? So now today, if you ask an insurance company to insure a hydrogen project, they will do it, right? But how would you expect, would you expect the insurance company to also offer additional assurance over long-term storage of hydrogen and provides a guarantee over the next 10, 20 years that nothing would happen, right? They will probably do it, but the insurance premium is probably going to be really expensive, and they all add up to the final hydrogen delivery cost. So I would say that in Southeast Asia, although you might be hearing what I'm saying is, there's bottlenecks and gridlocks everywhere, but the flip side of it is there's a lot of opportunities for new technology, new investment to address these issues and gaps. And also there's opportunities for ASEAN countries to work together, either bilaterally or on a multilateral basis, so that we can collectively expand the demand for hydrogen through some common downstream use case scenario. For example, maybe a gas turbine technology, for example, power generation, or maybe industrial boilers for the refineries, right? Or maybe something more flashy on the transportation, on the mobility, hydrogen fuel cell cars, which is being developed in many countries are looking at it. And this also enable ASEAN to work with outside region, with, for example, Germany, with US and Japan, in looking at technology transfer in this downstream use case scenario, so that when we produce hydrogen within the region, it makes sense because we also can absorb or use those hydrogen being produced. And that would also enable more energy resilience or energy strategies within the region in energy transition. And so also bring the region nicely into the greater Asia Pacific or ASEAN global decarbonization picture. So I think that would really make sense for ASEAN going forward.
Thank you very much, Victor. Yeah, I really liked that what you said complements to what Matthew said, because hydrogen technology before was used mainly in space, very limited applications on Earth. So we are bringing this new technology, and we have to, like Matthew said, build the infrastructure from scratch. And that's what you said. The government here plays a big role because we want to stay safe. Like we don't want explosive gas to explode, right? So you said government need to set up regulation. So I think that's what very relevant to Saulier, because Saulier wrote in chat that government of Kazakhstan working on a roadmap map for hydrogen, and many countries already implemented, like India, national hydrogen strategy. But still many countries, I think, working like right now on their roadmap of strategy. So that's very useful for them. So what Victor said, like to work on whole ecosystem, not just on one side, because we're bringing this technology from space to earth. And I think we need to build infrastructure from scratch, what Matthew said. And Victor said government need to work on regulations, legislation, safety, also risks associated with hydrogen, because it's I think like high risk, not only financial risks or investment risk, there's also explosion risks, and like because it's a gas, and also bringing sectors like insurance companies, right, and banks, financial sectors is government with working with financial sectors like insurance is also important. Yeah, thank you very much. And then question which Victor asked, actually, like what applications, like which sectors should apply. So the same question I can ask Eric Zussman, who so what do you think, which sectors, what are applications of hydrogen we can expect, or most useful, or no, sorry, most, how to say, yeah, what applications we can expect, yeah, which sectors and applications?
Yeah, thanks a lot, Dina, and thanks a lot, Victor and Matthew. And I'm going to sort of draw upon some of the insights from previous colleagues and highlight a few key points that I think are quite relevant to underlining the value addition and the unique properties of hydrogen. But to do that, I want to emphasize, I mean, we've talked a lot about some of the risks and some of the costs of hydrogen, and particularly some of the barriers to making, you know, we've heard the hydrogen society or creating a hydrogen ecosystem. But I think ultimately, in order to mainstream, especially green hydrogen, we need to think about this from a political economy perspective. And my impression is that the political economy dimension has not received enough attention in this regard. And I think in order to make hydrogen politically, economically attractive, so I'm talking about to people that are getting elected, to public office. I'm talking about people that are high-level officials in ministries that don't understand necessarily the technical details. We really need to emphasize the benefit story of hydrogen and the multiple benefits. So this was implied a little bit in Nandu's presentation when he talked about co-benefits. But I think so on the environmental side, of course, there's the climate change benefits, but I think there's also significant air quality benefits from green hydrogen. And those air quality benefits also link into health benefits. And I think if we can do a better job of, especially from a researcher's perspective and policy research perspective, of quantifying and monetizing some of those benefits, then we can, provide politicians, as opposed to just policymakers, politicians, with a stronger narrative and a more salient case for putting in place some of the regulations and clarifying some of the safeguards. So the benefit story, I think, needs to be highlighted quite a bit more. And also on the benefit side, I think one of the big things that's been underplayed so far, especially when we start talking about supply chains, is jobs. I think if this is done correctly, with the energy transition more generally, but specifically with hydrogen, is done more general. If it's done correctly, there's a significant opportunity to create jobs across the supply chain. And this is once again a politically salient argument, which is slightly different from the sort of typical benefits of hydrogen, in that if you can generate jobs, those are very near term, they're very local, and they're very certain. And in many ways, that's the opposite benefit profile of hydrogen right now, where it's a little bit more long-term, a little bit more regional to global in terms of some of the, especially the climate benefits, and a little bit uncertain. So by translating that benefit profile into jobs, I think then we have a stronger political economy case. And then the last point that I'd like to highlight, and this was implied in our presentation from Kazakhstan, and it also points a little bit to some of the political economy arguments too, is I think it's good to think about, of course, benefits and then also some of the trade-offs and how we can possibly minimize some of the trade-offs. So for instance, we heard in Kazakhstan, there might be some water scarcity issues. So how do we create policy in a way that will maximize benefits and minimize some of the trade-offs of pursuing transition pathways towards hydrogen? I think we'll have perhaps a second question, and I'll talk a little bit more about those transition pathways and perhaps my second question, but those are some points I'd like to highlight. Thank you very much.
Yeah, thank you very much, Eric, for your answer, and also especially referring to previous presentations. We have just 10 minutes left, and at the end, let's take a photo. But before that, let's take some questions. So dear audience, please don't be shy. If you have questions, just type them in chat, or if you want, you can even unmute yourself and just put your camera on and talk to us. Okay, please. Any questions? Speakers also can ask. Yeah. Because if no questions, I have questions, of course.
Dina, can I ask a question?
Yeah, please.
This is actually for anybody. I think one of the things that I noticed, especially from some of the earlier presentations, is still that I think there's a challenge here in trying to communicate a lot of the, for lack of a better term, the science and the technical details of hydrogen to policymakers. So I'm wondering if anybody in the panel or from the presentations can talk a little bit about some of their experiences communicating to policymakers how to translate some of these technical details into, robust regulations. So, Victor, I think, mentioned this, and Matthew perhaps mentioned this too. How do we explain to folks in Indonesia or Singapore how to put in place the regulations that create for a stable investment framework?
Thank you, Osman, for the question. And this is a real critical one, because if the regulatory framework is not ready or hydrogen friendly, there is no project. So at the end of the day, one of the key steps in any countries we go is to meet the key ministries to understand what is the current regulation, to make them understand what we are proposing and how both can match. And these are very complicated discussions, because a country won't necessarily adapt their regulation based on the request of one single company. So I don't have a very clear answer to propose, but today our approach is that in a very empiric manner, to address one by one the key ministries and the ones who are involved on the eventual hydrogen regulation, to explain what we do in the power sector, because most of the time today we will promote hydrogen for power application, and we see with them if it can be compatible with the current regulation, why, how. One of the leverage we use sometimes is to see if the development agencies, like I just give example, I don't think they are involved, but like a World Bank, ADBI, French Development Agency, KfW, whatever, we try to see if we can get some support for such international stakeholders to bring comfort to the local ministries. Because in your question, one of the topic was, how do we explain that to the local stakeholders? It's not that easy. On our side, we are a medium-sized French companies in Asia who are totally unknown. Even though we did some stuff in Europe, it's super far away. And one of the ways we try to access better to those people and to bring them comfort is by involving those international agencies. And as an example, in Indonesia, the project we have under development, we join forces with GIZ from Germany, UK FCDO from UK. We are talking to DFC from USA, ADBI. And that is a way also to make understand the Ministry of Energy that which is quite supportive in Indonesia, to make them understand, okay, we propose something new, it involves hydrogen, it involves new technology, even though we said it's not new, but it is seen as new locally. But look at the supports we get from the development agencies, and step by step, it helps to have availability and open minds to find solutions on the regulatory framework. So today, this is our approach, but definitely this is a complicated topic.
Yes. Well, I mean, I completely agree. So, you know, not in the Singapore context, I guess in many countries' context, this is where I like to use that nuclear joke all the time. So, you know, people always say, if you really follow climate science and you listen to the scientists and engineers, you know, we should have a nuclear power plant all the way until now, right? I mean, Fukushima should be nothing. Then you would listen to another group of scientists and policymakers and say, you know, well, actually, if you really do follow the science and engineering, we should have never had nuclear energy because of whatever issues that we are seeing. So I guess it depends, you know, sometimes it depends on which camp and who you do listen to and what kind of science they were looking at. Eventually that will land to policy. But fortunately, I think in the region, you know, we are at a stage where we are more informed with this globalization of information, IoT, data availability. You know, you can just do a search and you know, look at what is there, what people are talking about, and you know, make an more or less informed decision. You can also engage the different groupings, and I mean, for example, what we do in the region is we provide independent assessment for countries. So if they want to look at hydrogen, we'll be doing a specific analysis and looking at what are the ways for them to enter, basically looking for entrance strategy, right, for countries. What are the first steps that should take and who are there to support the country's hydrogen agenda. But then, of course, whenever you talk to an agency in Singapore or in national government in Southeast Asia, you will definitely hear this. Well, hydrogen, yes, we love it. We would love to have hydrogen, but we don't know how to go about with it. How to go about doing it? You know, we don't know when to use it. We don't know how we should have hydrogen in our energy economy. So that's where I think, you know, this whole ecosystem approach will give the countries more assurance in saying that, you know, you're not going to be alone. Right? You're part of this whole ecosystem. There are companies supporting your agenda, and your policy should be designed or redesigned or improved in ways that it would help facilitate, you know, the adoption of hydrogen. I mean, facilitate is a big word to use, but at least have a regulatory and policy framework that would not prevent or rule out hydrogen as an option. Try 1 or 2 pilot projects and see what it is in it for you, for a country to adopt it. And so I think, in a way, that's what, you know, how Singapore is taking the approach, you know, from the research foundations or the agencies. They will put in some test bedding money, try out, for example, small scale hydrogen combustion research, looking at, well, I mean, I don't know what the chemical engineering things are, but yeah, you know, research like that to look at hydrogen production, to look at downstream use cases, and to really understand, if we go down the path of hydrogen, what are the implications? Not just, you know, not just technical cost implications, but policy implications, right? One thing, you know, I think a lot of countries will be thinking about, they might or might not have realized that the moment we are talking about energy transition, we're talking about replacing jobs. We're talking about putting other industry at risk. So if you're talking about fossil fuel replacement, I think that's Matthew-based in Indonesia, you're talking about 1 million people's job at stake. Same thing with China, same thing with Vietnam. That's millions of jobs. I mean, if you simply replace those jobs, there's going to be a huge problem with economic development. So what are you going to do if energy transition does happen? And that is where you know, government will be cautious about taking any options. Same thing with nuclear, same thing with CCS, same thing with renewables. I mean, this all comes in with replacement. And I think, you know, if I was to think about, you know, where hydrogen can really make the case, is probably thinking about hydrogen as a collective, I mean, as an energy for collective good, not just within ASEAN, but also to export it. But then question is, if you want to enable hydrogen export, then you probably also need to think about your national energy strategy, because that will increase your energy consumption probably, right? So you need to find a sustainable source of energy to compensate for that increase. And if you're looking at domestic use, then yes, which sector are you prepared to try and sacrifice as a first step, right, in that replacement. So I guess, you know, then the policymaker can easily come back and say, you know, this is just too much, right? So let's put it on 2050. It's long enough. We will think about it in the meantime. We look at what is going to be available. But then again, science plays both the devil's advocate and also the angel's advocate. And so which direction is going to go is I guess I still think is a big question mark in ASEAN.
Thank you very much. Yeah, Eric, excellent question. Yeah, and thank you very much, Matthew and Victor, for replying. Yeah, actually, I didn't ask this question myself. Like, I was now, since Eric asked, like, who are main stakeholders in the government, to whom to talk, right? It's like Matthew said, because they are working in power sector, that's Ministry of Energy. But the hydrogen is not only in power, right? It's also affect transport, vehicles, transportation itself, like shipping, and industries, other production industries. Then, like so many, I think ministries, stakeholders will need to be involved, and then how to make them like coordinate all together. That's even more complicated. Yeah, I think even this question, like who are the stakeholders in each country. And also Victor raised important question, like what this transition, even green transition, it's nice, but what disturbances it will bring to, what are risks for other sectors, employment, especially like in some countries there are whole towns who depend on coal extraction and coal mining. Yeah, actually we have a call for paper I shared on chat specifically for these two topics. One is on hydrogen, and another one all from coal to energy transition. So we actually specifically want to hear your thoughts on this. So please, anyone welcome to contribute. So since time at 9:30, I think we're done.